Video, I will let you know the 10 most common types of questions in permutation and combinations. I will start with an example and I will build up more questions just like that in different situations so that you are clear about how to go about those questions. One thing I want to make clear in this that they are not in any order, so they come equally likely in exams. So you should not be worried which one is most common and which one is least common. So let's start with the first. This is type 1. A competition involves listing in order. That means order is important of the best 6 features in a certain car. There are 10 features to choose from: power steering, airbags, air conditioning, and types of tires. It could be color and all that. Peter makes a list of his best 6 features. How many different lists could Peter make? So Peter is one person and he has 10 options and he has to choose one. But suppose he gives safety the first priority. Airbags are his first priority. And number 2 is air conditioning. Okay. And there will be 4 more after this. But if I say that he gives preference to air conditioning and then he gives second preference to color of the car. So here the air conditioner is number 2, here air conditioner is number 1. This is a different case. Alright? If it was not color and in place of color it is airbags, and the rest of the 4 selections are exactly same, but the order has changed here, that is a different case. Alright? That means in such case when order is important, we use permutation P. So there are 10 features to choose from and 6 in order. So 10p6 will be the answer. If we put this in a calculator, that will be the solution, which comes out to be 151,200. Now, what other kind of questions can be set up like this? Another question could be that there is a race in which 8 participants are running. Okay, there will be 3 winners. They will get the position 1, 2 and 3. So since the position is different, if runner number 7 gets the first position or third position, it's a different situation. If only these athletes win 5, 8 and 3, but their positions are different, they are different situations. That means order is important in this case also, and in what order they finish the race. So in this case we will use 8p3. One more example. We are trying to select a president, a secretary, a treasurer. Let's make one more. Let's make vice president also. 4 positions from a committee which has 20 members. From those 20 members, we have to select these 4 positions, 1 each, right? So if the member number 15 becomes treasurer or he becomes vice president, they are totally different situations. The positions have been named, just like 1, 2, 3 were named in the previous question. Here they have been named as president, secretary, treasurer and VP. So in such case also, we will use 20p4. There are 4 positions. Type 2. The word mobile consists of 3 consonants MBL and 3 vowels OIE. How many different arrangements of all the letters of the word mobile are possible if the vowels must be next to each other? In such case, what should we do? Let's put vowels next to each other and put a box around them. I, E and O. These are the 3 vowels in this. Now remaining are 3 consonants M, B, L. I'm not writing that. That means whenever these three vowels move, they move together. So if they take this second place, they will take it together. And means wherever they go, they will be together. And that makes it just four-letter word because they will act as one entity. They are one body now. They will move together anywhere they want. So whenever you have four places and four options, your options become 4 factorial. Or you can look at this question this way also. There will be four candidates for the first place, three candidates for the second place, two for the third, and one for the last one. That if we multiply these, it becomes 4 factorial. Originally, they are 6 letters, but we have reduced them to 4 because we took I, E, O as one entity. So our arrangements of those 4 will be 4 factorial. But inside this box, this I and E and O, they can also interchange their places. So there are 3 places inside the box and there are 3 vowels taking them. So we'll multiply this arrangement by 3 factorial and that becomes the final answer. If you put this in a calculator, you get 144 arrangements. So let's build up more examples on such question. Suppose I have another letter. Okay, so let's say I have another word which is, let's say, assessment. Big one. And in mobile, no letter was repeating. Here some letters are repeating. Alright, so let's count how many letters does assessment has. 3, 4, 5, 6, 7, 8, 9, 10. So obviously 10 places and 10 of them will be taken by the 10 letters. So 10 factorial are number of arrangements. But there's no other condition given, right? But if this S and this S interchange the place, or for that matter, they interchange their places with these S's, they're not going to change the word. A word will still be same and will not know which S is which one. So in such case, when the letters repeat, we divide the whole arrangement by the factorial of those number of letters. So S is repeating 4 times. So it will be divided by 4 factorial. What else is repeating? E is repeating twice. So there will be 2 factorial again, because this E and this E, if they interchange their places, that's not going to affect the word. And this is the number of letters. Now, we did not say that some of them should be together or not. So let's say assessment. In the same, I want all S's to be together. Alright. So what will I do? I'll make a box for 4 S's. S, 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 S. Right? Now what is left? There will be 6 places left. 2, 3, 4, 5, 6. And this S box will be 7th. So it will be 7 factorial. This S is, there is no other box like this SS. So I will not divide it by 4 factorial right now. But let's see what I do next for the others. E will be repeating. So it will be divided by 2 factorial because E will be somewhere here. And those t E's, if they change their places, they will still be 7 factorial by 2 factorial. So this is there. Now let's talk about the box. It should be 4 factorial, right? 4 places, 4 S's, 4 factorial. But all the S's are same. So that's not going to make any difference. That means this is the only arrangement. Even if we interchange the places, they will still be same. So our answer is 7 factorial over 2 factorial. Let's make one more question. There are 8 friends, right? And 2 of them are very fast friends. They want to stand in a line. Okay, 1, 2, 3, 4, 5, 6, 7, 8. But 2 of them, the fast friends, they want to stand together. Just like the 3 vowels in that question wanted to be together. So let's make a box for those 2 friends. So friend 1 and friend 2. They will always be standing together. Other 6 friends, they can be anywhere because they are not that fast. So if we make this a box, it makes it how many? 7 places now. And 7 places will be taken by 7 people and it will become 7 factorial. But since these two friends are different, they're different looking, they're different people, so they can change their place again inside the box, so it will be multiplied by 2 factorial and whatever is the answer. These are the different types of questions based on letters and something being together. This is type 3 of the question. First two we have already talked about, but we'll again redo this for the sake of practice. And number 3 is the new one. So let me do the first two and we'll go to the third later. The digits are 1, 2, 2, 3, 6, 7, 8, and we want to make 7-digit numbers out of them. So it's just like the word we practiced before this, assessment. So 1, 2, 2, 3, 6, we want 7-digit number, so it will be 7 factorial. That will be 7-digit number. There are 7 of them, right? Yeah. But 2 is repeating. So 2 is not because of the digit 2. It is because their number are 2 and 2. And they can take each other's place. So we divide it by 2 factorial and that will be the answer. Okay. This is number 1. Number 2. The digits 1, 3, 7 in any order are next to each other. In any order they have said, this is very important here. It is different than what we did earlier. So 1, 3, 7. Let's make a box around 1, 3, 7. Okay, and how many places left now? 1, 2, 3, 4. Okay, now there are how many places actually? Now this becomes 1 place and there are 4 more. So there will be 5 factorial ways. Now we know that 2 is outside somewhere here, so we have to divide it by 2 factorial because they can take each other's place, multiplied by then this 1, 3, 7 can take each other's place. So in the inside box also we have 3 places for 3 digits and we have to multiply with that. So whatever that gives you, this is the answer. Okay. Next, number 3. So in this case they're saying that the 7-digit number are even. So what will make this number even? If the last digits are 2, 6 or 8. Since 2 is repeating, so let's separate 2. So 1, 2, 3, 4, 5, 6, 7, and I have given 2 to the last digit. That means 2 is the only one option here, right? Now the other 2 can come anywhere here. So it will join the remaining possibilities at the first place, and it will be 6. The remaining 6 can come here. Now 2 places are taken, so this will have 5, then 4, then 3, then 2, and then 1. And in such case, we just multiply the number of options we have, and it is actually 6 factorial. Let's talk about the rest of the 2, 6 and 8. 3, 4, 5, 6, 7, 7. Okay, no 8. So in this place, we have 2 candidates now, 6 and 8. So 2 of them we can take this place, right? Now, how many options are available for the first digit? Only one has taken, right? There are 2 options, but only one has taken this place, 6 or 8, one of them. That means remaining are 6 again, right? 5, 4, 3, 2, 1. And we multiply them, which comes out to be 6 factorial multiplied by 2. But we have to be very, very alert. We have to know that out of these digits, somewhere we have 2 2's, isn't it? We have 2 2's. And if they take each other's place, it will be the same number again. So we have to divide this whole number by 2 factorial. And 2 factorial is actually 2, so we can cancel 2 and 2. So it is again 6 factorial. So 6 factorial plus 6 factorial will be the answer. I think that will be 1440. What other kind of questions can be formed on this? So the question is that it's a 5-digit number, 1, 2, 3, 4, 5-digit number, and the options are let's say 0, 1, 2, 5, 8. They have 5-digit number and 5 options, right? And we want an even number made of these 5 digits. None of them is repeating, but we want an even number. The problem with this that 0 can give us an even number, right? But in that case, the first digit cannot be 0. So there will be a different case for 0, 2 and 8. So let's separate 0 and 2 and 8 can be combined together. So let me start with 2 and 8 only. So 2 and 8 will make it even number, right? So but two options are there. Only one of them will occupy this place, but we will write 2 because there are two options. Now how many are left in the first digit? In the first digit, we are left with the rest of the 4, but 0 cannot be the first digit. Otherwise, it will not be a 5-digit number. So we will write that there are just 3 options for the first digit. 1 has been taken up here and 0 cannot be used here. So we have just 3 options. And now 3 options for here as well. Why? Because 0 can be written here and the remaining 2. That makes it 3. And then this will be 2 and this will be 1. If I multiply this, 9 times 18 and 36. Now we have to take the case where the unit digit has been taken up by 0. So there is only one option here. What about the rest 4? We have 4 options for this one. 3, 2, 1. In this case, this will be 4 because 0 cannot be the first digit, but 0 has taken up this unit digit already, so it will not be repeated. So 4, 3, 2, 1, that makes it 4 factorial, which is 24. And now we can add 36 and 24. Total 60 options are there. This is type 4 of the questions, where they're saying a collection of 18 books contain one Harry Potter book. Linda is going to choose 6 of these books to take on holidays. First part says, in how many ways can she choose 6 books? They have not mentioned Harry Potter anywhere. So just any 6 books are to be chosen. The word here is chosen. Whenever they say chosen or selected, we use combination C. There are total 18 books and we have to choose 6. That will be the number of ways it can be chosen. The order is not important. Any book which is chosen first and which is chosen 5th or 6th, it is selected. No matter at what position it was selected. The final thing is that they should be selected. So 18C6 will be 18,564. Now, second part. In how many ways of these choices will include Harry Potter book? Now Harry Potter book has to be there and there is only one Harry Potter book. That means one Harry Potter book is selected, is there. No other option for that selection. We have to choose just 5 now from the remaining 17 books. And 17C5, that will be the answer, 6188. So let's make up a question that we have, there are 10 boys, okay, and 4 are to be selected again, okay. They are not being given any number first, second, third, fourth, so they are being selected and we will use combination. These 10 boys have one set of twins, so there are 2 twins. If 4 are to be selected, there can be many possibilities. So first one will be that at least one twin must be there, selected, okay. Second condition, only one of the twins is selected. And third possible, that is none of the twins is selected. So let's start with the third condition first. None of the twins is selected. In how many ways that can happen? That means those 2 are out of contention now. So out of 10 boys, only 8 are left to be selected. From where we have to select how many now? Because 4 are still there. Those twins are not part of it anymore. 8C4 will be the answer of this because twins are not in contention. Let's talk about this. Only one twin is selected. So even though the 2 twins are 2 people, that means either T1 will be selected or T2 will be selected. Let's talk about T1. Since T1 is already selected and T2 cannot be selected because we want only one of them, that means remaining are 8 people and we have to select 3, right? Similarly, if T2 is selected, so we'll have 8C3. So just add them. Either this will happen or this will happen. Add them, or you can just write 2 times 8C3 and whatever that answer gives. That is the solution for this one. Only one twin is selected. Let's talk about that at least one twin must be selected. At least one of them. So there are two ways of doing it. One is that we subtract from total. There are how many? 10 people. We are selecting how many? 4 people. Subtract that none of them is selected. 8C4. When we outrightly exclude these cases that none of the twins are there, that means at least one of them is there. If we subtract it from total. And that will be the answer of at least one is selected. Alright. What is the second way? Second way is this. T1 is selected, which is 8C3, or T2 is selected, right, which is 8C3 again, or both are selected, because there's at least this side, right? Both are selected. So both are selected, we'll have both are there in the team. So remaining are how many people? 8, and we have to select just 2 out of them because 2 seats have been taken by both of them. So our total answer will be 8C3, this one, plus 8C3 and plus 8C2, this one. So if I write this, whatever number it gives you, it will be exactly same as this one. Type 5 question is just like type 4 but in little elaborate way. It says a committee of 5 people is to be chosen from 6 men and 4 women. So we have 6 men and 4 women. Okay, total 10 people. All right, in how many ways can this be done? We have to select again, chosen or select 5 people. So the first one says if there must be 3 men and 2 women in the committee. So 3 plus 2 is 5, that makes sense. So we have to select 3 men out of 6 men. So it will become 6C3. Now it's independent to select 2 women from 4 women. So we'll multiply this with the previous one. So 4C2 and whatever answer that gives you, that is the answer of part 1. 2 marks for this. All right. Number 2, if there must be more men than women in committee. Now this needs some thought and we should see the combinations possible. So let's say men and women. So we need total 5. So it's possible that 3 men are there and 2 women are there. So there are more men than women. So we can have 4 and 1. It's also possible that all 5 are men and there is no woman. These are the 3 cases, right? Just like we did in part 1, we'll just count them one by one, how many selections are possible. So 6 men, we have to choose 2. Oh, this first answer is already there. 6C3, 4C2 is whatever answer we get from here. Now the second one will be 6C4 multiplied by 4C1, 4 men, 1 woman. And third one will give us 6C5 multiplied by 4C0. So whatever number the answers give individually, that will be the answer. And let me use my calculator to do that. And my calculator gave me 120 for this, so this will be 120, this is 60, and this is just 6. Total it becomes 186 types of selections. All right, let's go to the part 3. If there must be 3 men and 2 women, okay, and one particular woman refuses to be on the committee with one particular man. All right, okay, that makes it a little difficult. So part 3, either the man should be in the committee or that woman should be in the committee. So let's say that the man is in committee. That means The woman will not be, she will refuse. So if that man is already in the committee, that means there are now 5 men are left, out of which we have to select 2 men, because total 3 men are there. 1 man is already in the committee, 2 more to be selected from remaining 5. 5C2. That means there are 3 men and 2 women will be there. The woman will refuse, so will be 3 women left, and we have to select 2 out of them. So we'll find out this. Second case can be that woman is in the committee. Because she refused to be in committee, that means in this case she accepted to be in committee because the man is not there. So in that case, we will select 5C3. We will select 3 men from the remaining 5, and this woman is definitely there. So we have to select only 1 woman now for remaining 3 women. And there is a possibility that none of the 2 are in committee. That is also a possibility, right? There's no chance that the woman has to refuse because even the man is not there and she's also not selected. So we can say that man is not in the committee. That means all 3 men are from other 5 people. And the woman is also not in the committee. That means it has been from other 3 women. So let's see what these give me. When I use my calculator, I get 30 here, 30 here, and 30 here. Total 30 plus 30 plus 30, 90 selections are possible. This is type 6 question, in which they're asking in how many ways can a group of 14 people eating at a restaurant be divided between 3 tables seating 5, 5 and 4. Since they are fixed, you need any 5 people on the first table, any 5 on the second, and 4 on the third table. So we can select first 5 people out of 14. So it will be 14C5. And we ask them to sit on the table. Now remaining are 9 people. So we'll multiply, next selection will be 9C5. Out of those 9, we'll select 5. Now remaining are 4. So we will select all 4, which is just one case. 4C4 is 1. Just multiply this and we get 2, 5, 2, 2, 5, 2. These are the selections possible in that case. Similar question. Let's have one more similar question where some people want to go to airport. We have 3 taxis. Each taxi can occupy 4 people. And we have total of 13 people. Not 13, 11 people. 13 cannot go, right? All right, 13, 11 people we have. So, in how many ways we can arrange them in 3 taxis? So it will be the same way. 11C4. 4 people are selected for the first taxi. They sit in the taxi and go. Any 4. Remaining are 7 people. So we'll select 4 again from those people and they will go. And remaining are 3 people which will take 3 seats in the taxi. The 4th seat will be vacant and that will be the answer. Some of you may think, why don't we select 3 first and then 4 and then 4? Yes, we can do that. 11C3 first. Yeah, the remaining are 8C4 and 4C4. That is also okay, no problem. You will see that whatever we get here and whatever we get here number, both will be exactly same. It does not matter which one you select first. This is type 7 question. First 2 we have done. The third part is different, so this will make it a type 7 question. They say a staff car at a school has 13 parking spaces. There are 9 cars to be parked. That means 4 of them will remain empty. The first part says how many different arrangements are there for parking the 9 cars and leaving 4 empty spaces. So since we have 13 available slots and we want to park 9 cars and if a car number 6 is at the spot number 1 or 13, it's a different case. It is parked but at a different place. So arrangement is different. That's why we're using permutation here. And that will be the answer of the first one, 13P9. Part 2 says that how many different arrangements are there if 4 empty spaces are next to each other. So 1, 2, 3, 4. These are 4 empty spaces and I'm putting them inside a box. The remaining are 9. 3, 4, 5, 6, 7, 8, 9. Now this box will move together wherever it goes. So now we have 9 of these plus 1 of this, so 10. And they can take any space in 10 places. So 10 factorial will be the solution of number 2. Let's talk about number 3. In the parking, if the parking is random, find the probability that there will not be 4 empty spaces next to each other. That means we can have 3 empty spaces and the 4th one somewhere else, but not all 4 of them together. So basically, probability they're asking. So we will write, first we'll find the probability of empty spaces together. Sorry for the drawing, my pen is not working that well today. So, we have 10 factorial empty spaces together, divide by 13P9, the total number of arrangements. This is the probability that they are together. But they said they should not be together, all 4 of them. So we will subtract from 1 and this will be our answer. Let me use my calculator and give you the final answer. Okay, this comes out to be 0.986. Okay, the second one was 3628800 and the first one 13P9 was 259,459,200. Sometimes they complicate the things by making it a little difficult. Let me give you an example. So there are, say, 10 people. Okay, they have to stand in a line. Right? So 10 people, 10 places, we know the total number of arrangements will be 10 factorial. Right? When the number of spaces and number of people are equal, the factorial of that number is the total number of arrangements. But they can give a situation where there are 4 people, and when these people are together, they always disturb the rest of the 6. So the person who is making the arrangement doesn't want these 4 people to be together. What it means? Not even 3 of them should be together, not even 2 of them. Everyone should be alone. And that is the difference from the previous question where 3 empty spaces could have been together. But here these people, 4 people will not be together. So what will we do? In such cases, always do the remaining people. How many are the remaining people? 6. Ask them to stand. So these 6 people will stand here. Number 1 person, number 2, number 3, number 4, number 5, number 6. Now remaining are those 4 people who will stand somewhere between them. Here, they can stand quarter also, or here, or here, or here, or here, or here. That means that there are 7 empty spaces where these 4 people have to stand, so that there is someone between them. 1 person or 2 person doesn't matter. So what we have to do, we have 7 empty spaces. We will ask these 4 people, rather we will use P here because arrangement is important, right? Who is standing where? 7P4. Out of these 7 places, we will let these 4 people stand at certain place. And we'll multiply this by the 6 factorial because these 6 people can also change their places with each other. So it is possible that they take the corner seat. So let me draw some random arrows where they are standing. These are the arrows I have drawn. These four people stood there. That means number 3 and 4 people, they are together. There is no one in between them. Here is a very common question of permutation and combination, where they say that there are 10 people, they meet each other, each shakes hand only once with each other. How many handshakes will be there? So sometimes they make this 10 as 20 people, sometimes 100, 2000, 5000. The method remains same. So let's try to analyze this. So suppose there were 4 people, not 10 people, 4 people. All right? So this person at the left up corners, so he will shake hand with these 3 people, right? 3 handshakes will take place. Let's talk about this second person. He will shake hand with this, but this handshake has already taken place with the one person. So he will not take place of this. So basically there will be how many lines here? 1, 2, 3, 4, 5, 6. 6 handshakes, right? But this was a visual way of explaining things. How do we do that mathematically? So we know that there are 4 people, they shook hand with 3 other people each, but the handshaking of 2 people with each other was same event. So we have divided by 2. And that's how we get 6 handshakes. So our question here was 10. So we will do here 10, they shake hand with 9 others, but it will be divided by 2. That comes out with 45 handshakes. Alright? Similarly, if we can do it for 50, 100, 1000, 2000, 5000. How about combination? There are 10 people here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We will choose any 2 of the people and ask them to handshake. Right? So we chose 2 out of 10. But we will not choose these 2 again to have another handshake. They will have only one handshake. That means there were 10 people, we chose 2, and that is also 45. So this is the shortcut. 10C2 will also give you the same thing as we did earlier, logical way. Where can we use such a situation again? Sometimes there are some leagues, right? Some sports leagues. So what happens in those leagues, that each team plays with another team in round robin basis. So most of the leagues have say 20 teams or 30 teams. They will play with each other only once. It's like handshake. So if there are 20 teams like in EPL, they play with each other twice. So first we'll say in one leg of the tournament, how many games will be played? So 20C2 will be the number of games in one leg, and then they will go to each other's place. So we'll multiply 2, and they will be 380 games in EPL, and that's what happens every year. There can be one more usage of this where we have a polygon. Suppose we have a polygon, we don't know how this polygon looks like. Okay, this is the polygon, maybe a hexagon, right? We want to know how many diagonals will this polygon has, right? So what do? It's like handshake again. So we will write the 6C2, right? They are the number of ways they are connected with others. But these sides, outer sides, are not diagonals. So we'll subtract the number of sides that polygon has. So 6C2 minus 6 will be the number of diagonals for any polynomial, even if it is a polynomial with 20 sides. So we will have 20C2 minus number of sides that has, because we have to exclude those sides. In that kind of question, we have some hint from previous ones, but we'll build on it. In how many combinations can I wear a shirt, a trouser and a tie from 5 shirts, 4 trousers and 10 ties? Since I want to choose one shirt, I have 5 options. Similarly, I want to choose one trouser, I have 4 options. And for ties, I have 10 options. And that will give me 200 combinations. Okay, that's straightforward. But sometimes it can become a little complicated by changing the question. In total, how many factors 288 has? We want to find its factors. In such case, what do? We carry out prime factorization. So it is 12 times 24. Then we can again do it 3 times 4 and 2 times 2. 24 can be 8 times 3. Then we have, we can do 2, 2 and 2. So we can see there that there are how many 3's? 1 and 2 3's, right? So 3 squared. How many 2's? 1, 2, 3, 4, 5. 2 to the power 5. Now I want to know how many factors does 288 has. So all the factors are combination of 3's and 2's. So how many 3's are available to me? 2 3's. But I can choose that I don't want to use any of the 3's. That means I have 3 options for 3. I have 5 options for 2, but I can choose that I don't want to use 2 anyhow. So I have 6 options, 1 more than the exponent we have. 1 more than 2 is 3, 1 more than 5 is 6. I can choose not to use any one of them also. So that's how 1 becomes the factor of 288, because there is no 3 in it, there is no 2 in it. So wherever you want to find total number of factors of a number, carry out prime factorization and write them in exponential form like this, and then add 1 to their exponents and multiply the exponents, because that gives us the choice how many of them we want to use. The main difference between the two examples I have given is that in shirts, trousers and ties, there was no option of not choosing any one, because I can't go out without a shirt or a trouser or a tie. It's possible with a tie, but here in this question I would not. I have to choose them. But in the second part, we have a choice that not to use one of them. That adds to the options. That's why we increase the 2 options by 1 and 5 options by 1. Here they are asking, in how many ways can 4 letters be posted in 5 letter boxes? So I've drawn 5 letter boxes because they are fixed. We can't take them to letters, but we can take letters to the boxes. So I have the first letter in my hand. How many options do I have for that letter? I have 5 options. I can put it here, or here, or here, or here, or here. I have 5 options for that. Now I take the second letter. Second letter also can go in any of the 5 letters. As a result, it's possible that all 4 letters land up in same letter box. So we have 5 options for each letter, and that comes out to be 5 to the power 4. What else can be asked in this format? Okay, there are 10 toys, right? And there are 6 children. 1, 2, 3, 4, 5, 6 children, right? These 10 toys are to be distributed among these 6 children. So it's possible that all 10 toys are given to one child, right? It's also possible. So toys are moving, children are stationary. We have to give these toys to children. So the first toy, the option for first toy are 6 children. They can be given to any of the 6 children. Second toy, 6, and so on, which makes it 6 to the power 10. This is how we carry out the distribution, not arrangement, not selection.